ClickMyProject.com. Let us discuss our project. Our project title is A Novel Signal Modeling Approach for Classification of SEIZURE and SEIZURE-Free EEG Signals. Abstract. A new methodology of automatic seizure reduction in EEG signals by signal modeling is proposed in this paper. It consists three type stages. First, a multirate filterbank structures is proposed that is constructed using the basis vectors of DCT and decomposes EEG signals into its respective brain rhythm. Then brain rhythms are statistically modeled with the classification of two processes, that is FBM, fractional Brownian motion, and FGN, fractional Gaussian noises. Third, the value of Hurst exponent and the autoregressive moving average parameters are used as a features to design a binary SVM classifier to classify the detection of seizure-free and seizure intervals. The main objective of this process is to detect the epileptic seizure detection by an effective decomposition and classification. Also to improve the classification rate and accuracy range by estimation and by boosting the process. Now let us see the flow diagram of the project. First, data set. EEG database which was recorded with the University of Bonn. EEG signal dataset contains A to E, that is 5 sets A, B, C, D, E. Set A and B consist of a data collected from 5 healthy volunteers, and C, D, E are obtained from 5 epileptic patients undergoing pre-surgical evaluations using intracranial EEG recordings. Then set E extracts the exculpation and C and D seizure-free intervals. Then D is exculpations. That is Then the input of EEG signal consists of a time series of data evoked potentials resulting from the systematic neural activities in a brain. The recording data of human EEG are carried out by placing the electrodes on the scalp and plotted as a voltage magnitude against time. Second, pre-processing. EEG is recorded from many electrodes arranged in a particular pattern or montage. Common standard called the International 1020 system is used here. These methods are cheap and give a continuous record of brain activity with better than the millisecond resolution. Then EEG signal is decomposed into 5 brain rhythms, that is gamma, beta, theta, delta and alpha. Here gamma and delta waves frequencies is up to 3 Hz. It is lowest wave having highest amplitude. It dominant infants up to 1 year and adults in deep sleep. Theta waves, it is a slow wave with a frequency range from 4 Hz to 7. It emerges with the closing of eyes and with relaxation. It is normally seen in young children and in adults. Then alpha, it has a most common seen in adults. Alpha activity occurs rhythmically on both sides of head. It appears with closing eyes and disappears normally with open eyes. Beta waves, its activity is fast with a small amplitude, ranges up to 14 to 30 Hz. It is dominant in patients who are alert or anxious. Then future extraction. It is combined by both fractional Brownian motion and fractional Gaussian noise. It is collection of relevant information from the decomposition signal. Then the features are identified by this extraction and it is classified by support vector mission. It is a basic vector kernel classification for pattern recognition and detection. In machine learning, SVM also called as a support vector networks that analyze data used for classification and analysis. Finally, it estimates the performance by measure the accuracy, specificity and sensitivity. Now let us see the running procedure of the process. This is an Matlab 2017 version. It is on command window. Click the main file in the current folder. Click on right click and then click run button. It is our guide design, represents the classification of seizure and seizure-free EEG signals. First click the input EEG signal button. The data set which is asking. click on train files and selected any one EEG signal. First the signal is displayed, then size is too big to filter the signal, so click on resized signal push button, then it is decreased to 0 to 1500. Then click on decomposition. Gamma, beta, theta, delta and alpha brain rhythms are presented here. Already we are explained in the flow diagram of these decomposition levels. Then the extraction process. Click on FBM in feature extraction. The signal is displayed by taking an Hurst exponent. Then fractional Gaussian noise process. Next it is continued by analyzing the test feature and train feature values. Click on test feature button. The values are displayed. Then train features. Then EEG signal is identified by clicking on EEG signal identification push button. The signal is interictal. Then it estimates the performance by accuracy, sensitivity and specificity ranges. Then it is comparison the results. These are the procedures and explanations involved in this process. Thank you.